Okay, so we're going to go over these ones here, guys, and then we'll move on to some more of this prediction practice stuff here. All right, so on our first one, we've got sodium chloride reacting with calcium oxide. So two ionic compounds is what kind of reaction? Double replacement. So what do we do in double replacement? Swap metals. All right, so that means calcium ends up with chlorine, sodium ends up with oxygen. So I've got the pairs right now. What do I have to do with those? Drop and swap. Okay, so -2 plus 1, so this is Na2O. Okay, and sorry, I already wrote that one just because I think ahead of myself here. Okay, so 2 plus and 1 minus, so we got CaCl2 there. Now what do I have to do? Balance the reaction. All right, there's 2 chlorines over here. I need a 2 there, and that'll pretty much do it. Okay. Questions on that one? All right. So second one here, I've got iron 3 bromide, and I know that because there's 3 bromines here. Okay, and sulfur. What kind of reaction is that? Single replacement. Now, sulfur's a non-metal, so is it going to replace iron or bromine? Bromine. Okay, so iron ends up with sulfur, bromine ends up by itself. Okay, it says on our chart there, our flow chart, which you guys probably aren't even using anymore, okay, that we're supposed to check for special elements. Do I have any special elements? Yes, bromine is special, always comes as a 2. All right, and then I have this ionic compound. Iron's +3. Again, I figured that out because over here it was with bromine, okay, which meant it had to be a +3. All right, so 3 plus and -2, so we swap and drop. We got Fe2S3. All right, we always balance the thing present in the largest number first. There's 8 sulfurs over here, and there's 3 on that side. What's the lowest common multiple of 8 and 3? Yeah, 24. Okay, so I got to put an 8 here. I've got to put a 3 here to balance my sulfurs. And then I've got 16 irons, so I need a 16 here. 16 times 3 is 48. What times 2 give me 48? 24. It is unusual to get numbers that big, but it happens once in a while. All right. I would probably not on an exam give you one where you would have numbers that big because I think it might throw you. Okay, just to be dealing with numbers so large. Okay, number 3. I think we had that one yesterday. All right, we got carbon, hydrogen reacting with oxygen. What kind of reaction? Combustion. So products are always CO2 and water. All right, balance alphabetically and rule of 2. Do they both apply? Yes. Okay, so start with a 2. It gives me 16 carbons. 2 times 18 is 36, so I need an 18 there. And that gives me 16 times 2 is 32, plus 18 more is 50. I'm pretty sure we did that one yesterday. Okay, 25 there. Questions on those 3? Okay. Number 4, element plus element is what kind of a reaction, Keandra? Synthesis. Right. Okay, so I've got to put them together, Be with F, and then I've got to drop and swap. This is a +2, and this is a -1, so we got BeF2, and that'll do it, because it's already balanced. Okay. All right, only kind of reaction that starts with only one compound, Sasha. Decomposition. So it's going to break down into chromium and nitrogen. So I have to check for special elements. Chromium is not special because it's a metal, all right, but nitrogen is. All right, now what do I have to put over here? A 2, right? And then what do I have to put beside chromium? A 2, and now we're all balanced. Jace. It is a -3 charge, but when it is by itself, it comes as a pair of atoms. Yeah? Okay. Yeah, don't get the charge and that special number confused. The charge is used when you swap and drop it in a compound. The special number is the number you put beside it if it is an element by itself in a reaction. Okay? How many people have done all 10? All right, I'll give you a couple more minutes here to finish up the, or sorry, 11. Yeah, I'll give you a couple more minutes to finish them up, and then we'll go through the other 6 here. Alrighty, so for number 6, I have 2 ionic compounds reacting with each other. So that is double replacement. I'm going to swap barium for copper, okay, meaning that copper is going to end up with phosphates, PO4, and barium is going to end up with sulfate, SO4. Now, does it matter whether I put the copper-containing compound or the barium-containing compound first? It does not. Okay, so it doesn't matter whether I put, if I was to put barium sulfate here and copper phosphate over here, that doesn't matter. I always want to put the metal, then the non-metal in the compound, but whichever order you do this in really doesn't matter. Okay, all right, now I got to drop and swap these. Phosphate is a minus 3, and this time copper is plus 1 or plus 2? Plus 2, because sulfate is minus 2, and they're 1 to 1, so this has to be copper 2 sulfate. So that's going to mean a 2 here and a 3 there. All right, and barium is plus 2, sulfate is minus 2, so that compound is okay already. Now we got to balance the whole reaction. So there's 3 coppers over here, and there's 1 over here. So if I put a 3 there, that gives me 3 sulfates. So if I put a 3 here, that gives me the right number of sulfates and the right number of bariums, and now we're good. Okay. All right, number 7, decomposition reaction. We start out with only one compound, so it's going to break down into lithium metal and nitrogen gas, which is special. All right, now we need to balance. If I put a 3 here, then I have to start over again anyway, so I might as well start with the nitrogens and balance them, and that'll give me 6 lithium, and now it'll work. Okay, number 8. Carbon-hydrogen containing compound reacting with oxygen. Products will be CO2 and water. Okay, does the rule of 2 apply to this one? No, it does not. All right, so we put a 9 here to balance our carbons. We put a 10 here to balance our hydrogens. And we'll have 18 oxygens plus 10 more hydrogens, okay, is 28, which means we need a 14 there. Okay. All right, for number 9, we've got nickel reacting with phosphorus. Synthesis reaction, 2 elements. All right, so we have to put them together. Nickel and phosphorus together is nickel multivalent. Okay, most common charge is the one I have to use here because there's no way for me to know what it was over on this side, right? Nickel was by itself as an element. It has no charge, so I have to use the most common one, which is 2. Yeah, okay. So I've got plus 2 and minus 3, so we'll have Ni3P2 for our formula. And then we need to balance. Start with phosphorus, it's present in the largest number. Put a 2 here, that makes the phosphorus work, and a 6 here to make the nickel work. Questions on that one? All right. Okay, next one, we got an ionic compound reacting with an element, so single replacement reaction. Our lone element, metal or non-metal? Metal. So who's it going to switch with? Zinc or hydroxide? Zinc. All right, so potassium will end up with hydroxide. Zinc will end up by itself. -1 and +1, so that compound is fine. Zinc is not special, so it needs no small numbers. Okay, now we need to balance. There's 2 hydroxides over here. Now there are 2 on that side. That gives me 2 potassiums. Now there are 2 on this side. Okay. And lastly, potassium permanganate reacting with calcium nitrate. Double replacement reaction, so we swap the metals here, meaning that potassium will end up with nitrate, KNO3. Calcium will end up with permanganate. All right. This one here, the potassium nitrate is fine. It's 1 and 1, so okay. But calcium and permanganate are 2+ and -1, so we will need a 2 outside of the brackets on the permanganate. Okay. Now I have to balance, so I need a 2 here to give me the right number of permanganates, and then I need a 2 here to balance my potassiums, and that makes my nitrates balance. Okay, questions on those? How are we feeling about this stuff? Cool. Yeah, there's oxygen in 2 spots, yep. Yes. Reactants, yeah. Yes. Remember, we want the oxygens to be the same on both sides of the arrow. If oxygen is in two places on the product side, I do have to add them together to get the total on the products side. It has to equal the total on the reactant side. So yeah, that's what I've been doing, right? 9 times 2 is 18, plus 10 more is 28. 14 times 2 is 28. Yeah? So I got to make sure, yes, I do add them. And that'll happen occasionally. It happens every time you do a combustion reaction, yes. Other types of reactions, it's pretty rare, okay, where you'd have an element in two different places. Okay. All right, how are we feeling about this? Are we starting to get comfortable with it? Okay, it's a really important skill that we have to be able to do, okay, reliably here. All right, so other thing I wanted to show you here, guys, has to do with how you can submit stuff to me for review and even for marking, for that matter. Okay, if you sign in with your school email address, right? Because your guys' now end in gmail.com, right? Okay. No, they end in Redeemer or Isidore or something like. Yeah. Okay. Right. So if you sign into Google with your email address, okay, in the same way that I would, okay, it shows up here as got your login name. All right. Now, if I want to share something with somebody, I go to my drive. Okay, and it shows all of my files in here. Now, right now, I'm signed in as one of my other identities. Okay, so that's fine. If I want to share a file for somebody else to look at and edit, which is great if you want me to go over like your toxin project or your lab report or something like that, okay, you just click on that file, so check the box, like so. And then you'll get all these options up top. The one that has the picture of the person's silhouette and an addition sign is the share button. So I click on that, okay, this sign will come up. All right, now I've already shared that with myself as a test. That's why I appear twice on here. All right, but if I wanted to, let's say, share it with one of you and allow you to edit it, all I have to do is put in your email address down here, okay, in the invite people header. All right, if I put your email address in there, it'll send you an email, and it'll send you a link in that email that'll take you to that file, and you can edit it. And then when you're done, you just send it back to me. Okay? Or actually, you don't even have to send it back to me. If you just edit it and save, the save will show up. The new saved version of it will show up on here. Anybody got their tablet or laptop here? I'll show you how it works. Okay, Maddie. All right. So you highlight your file, just star it, whatever, or click on the checkbox, share it with me, kcodair@redeemer.ab.ca, and boom, you're in. Okay, it'll come to me. I can edit it as long as it's in a file format that I can actually open. All right, so that means it's got to be in either Word or Google Docs or something that I can open in Word. All right, I can't always open Pages stuff. I can if I have my iPad with me, but I don't always. So if you have a Mac and you did it in Pages, I may or may not be able to open it. All right, everybody follow me there? Okay, and it saves you having to print it or bring it on a stick or do whatever. Okay, you can just share it with me and I can quickly send back and I can edit right in the file. Okay, everybody follow? The option is there for you. All right, so number 11, okay, we have the camping lantern reaction. All right, reaction of calcium carbide and water to produce acetylene gas, which is C2H2, and calcium hydroxide. So write this reaction and balance it. So we've got CaC2, all right, plus water, H2O. Actually, because one of our products has hydroxide, I'm going to write water as HOH. Make this a little bit easier. Okay, to produce acetylene, C2H2, and calcium hydroxide, CaOH, right? And that is a 2 as well. All right, so now when I want to balance, I need a 2 here to balance my OHs and my H's, and that's it. That's all I need. Okay, it's tricky. It's tricky. Which 2s? No, that's for an ionic compound, right? We only reduce ionic compounds. This is molecular because carbon is listed first, right? So yeah, that's a tricky one because of that. Not really. Carbon can behave in even sometimes a positive fashion, and when it's in an organic compound. That's why you aren't given a charge on your periodic table. All right. Carbon doesn't usually get into ionic compounds. It usually only gets into organic compounds. Okay. Tasha? For number 8. Okay, so copper oxide reacts with carbon. So we're trying to make copper metal here, right? So we've got CuO plus C. Okay, and that's going to give us CO2 and Cu, right? It's not a true replacement reaction. It's one of the exceptions that kind of to the rules. Yeah, one of the exceptions to the rules. All right. That one's more of a, I just wanted to see if you could intuitively figure out who needed to go with who, because you're right, that's not an ionic compound, right? And a replacement reaction is supposed to make ionic compounds, but really there wasn't anywhere else for those two things to go, right? Yeah. But that's not balanced right now. But now it is. Okay. Yeah. Any others there, guys? All right. James? 5. Okay. Okay, so sodium chloride is in a solution with lead 2 nitrates. So NaCl, right? Swapped and dropped correctly. Lead 2 nitrate is PbNO3(2). You used this stuff in the lab the other day. Okay, you reacted it with potassium iodide and got the yellow precipitate. Okay, so we've got a double replacement reaction where sodium will end up with nitrate, -1 and +1, so that one's okay, and lead 2 chloride, PbCl2. Right. Then we have to balance, so a 2 there to balance the nitrates and a 2 there to balance the sodiums, and there's a 2 on the other side with the chlorines, so we're good. Okay. Any others there, guys? Okay.